Welcome to the Explore Composites Materials Library. This is laminate sample number 29. This one is just 2 plies of thin chopped strand mat. Here it is bending. And here's the laminate schedule. It's very simple, but there's an awful lot of resin and not much fiber. So we're going to start off talking about fiber volume fraction and chopped strand mat and what it's used for typically. It's got a binder in it, breaks down in styrene, and it's very conformable, wets out easily. It's good for skin coats and bonding core with polyester resin, places where you need extra resin. And it is not good for anything that's got to be light. It is not really compatible with epoxy, and it uses a ton of resin. So getting back to that resin, here I'm laying it up. This is an estimate of the fiber volume fraction of this piece, which you can see is 0.18, which is really not much fiber. And taking a look at a representative volume element here. This is fiber in a block showing the ratio of fiber to resin, the fiber volume fraction. And chopped strand mat is quasi-isotropic. You could build up a laminate by pointing unidirectional material in different ways, or you could use chopped strand mat, which is really more like a disc. It's pointing in every direction equally. That's great for some things, but for anything with strength requirements in one direction, you can see not much of the fiber is actually pointing in that one direction, and so it's not that useful. There are much better ways to do that. Taking a look at the actual layup, here's the first of the 2 plies and some polyester resin. This is just a general purpose resin. Wetting it out with a roller and a squeegee for a larger panel. Of course, it's easier to do with a paint roller, something like that, where you can spread the resin more readily. I didn't want to get one of those dirty for a small sample, so I'm just using this method here. And you can see there's a lot of resin. So I can almost wet out this second ply just with what was in the first ply, but in order to get it nice, I'm going to wet this one out completely till the fibers are clear. Now, this would cure to a surface like this, which would still be tacky because it's laminating resin. So I'm going to use a ply of this coated nylon peel ply over the top, and it's going to leave a nice smooth textured surface on it, and it's also going to let the resin fully cure underneath, and it'll just be tacky on the surface, and that surface will come off with the peel ply. So just wetting this through very carefully, let it gel, trim up the panel, and here it is. Pretty nice, not much air in the surface. You can definitely see fibers printed through. I'm going to pull off the rest of that peel ply, which peels off really nicely because it's coated. The thickness is about 0.053 inches or 1.25 millimeters. 5 ounces per square foot, which is about 142 grams a square foot or 1,526 grams per square meter. Here's a look at the finished sample. It's relatively stiff, but it's stiff because of its thickness, not because there's a lot of fiber in there. And we're going to compare it to a couple of other samples. You can see here shrinkage in the surface from the fibers, and it's relatively stiff. Now, I'm going to look at comparing it to laminate sample number 17, which you can check out. This is 2 plies of e-glass, and number 27, which is 2 plies of carbon. Both of these are in epoxy. Much thinner, much lighter. Thanks for checking it out.